In this video, we are going to differentiate between evaporation and boiling. Evaporation and boiling we often use interchangeably to represent phase change from a liquid state to a gaseous state. So what is boiling? Boiling is phase transition from liquid to gas, and when a substance boils, it bubbles and the particles move apart, moving more freely, randomly in all directions. The vapor pressure of the liquid at the boiling point equals the atmospheric pressure. So when a liquid boils, temperature does not change anymore until the liquid completely turns to a gas. Although you continue to apply heat to this liquid, after it boils, the heat applied will not cause a change in temperature, and that is because the heat absorbed at this stage is used in breaking the intermolecular bonds between the liquid molecules, helping them to move apart. This type of heat is called latent heat of fission. Now let's look at evaporation. Evaporation also involves phase change from the liquid state to the gaseous state. However, evaporation happens only on the surface of the liquid, where the particles that have sufficient kinetic energy can break away from the liquid structure, turning into gas. Evaporation can happen at any temperature. This is the reason why after it rains, even though the temperature of the day doesn't go quite up, all the puddle of water along the way dries up over time. This is the reason why even when it snows, water still evaporates. The rate of evaporation depends on temperature. The higher the temperature, the more particles will have sufficient energy to break away from the liquid structure and turn to the gas phase. Now let's differentiate boiling and evaporation. Where does boiling take place? Boiling takes place throughout the liquid. When you say a liquid has boiled, the whole liquid bubbles. Evaporation takes place on the surface of the liquid. So the water or the liquid evaporates gradually until it's completely gone. At what temperature will boiling happen? Boiling happens at a specific temperature. So different liquids have unique boiling points, whereas evaporation can happen at any temperature at all. Whether it's cold, whether it's warm, evaporation is going to happen. The only thing that will differ will be the rate at which the liquid evaporates. Does temperature change during the process? For boiling, no. For evaporation, yes. During boiling, the temperature of the system will stay the same until the whole liquid turns into the gaseous phase. Whereas during evaporation, the liquid can continue to evaporate while the temperature changes until it reaches the boiling point of the liquid. This explains why when you're boiling water, you can see some vapor rising from your kettle even before the water boils. What happens with change in altitude? Change in altitude would change the rate at which water boils or evaporates. Change in altitude would change pressure. Remember that we said that at boiling, the vapor pressure will equal atmospheric pressure. So when altitude is higher, pressure gets lower. And when you have lower pressure, your liquid will boil faster because boiling point will decrease. For evaporation, When you have a higher altitude, remember, pressure will decrease, temperature will also decrease. Decrease in temperature will cause evaporation to be slower, and a decrease in pressure will cause evaporation to be faster. So the overall change in temperature and pressure will determine how much of a difference that you have in your rate of evaporation. Now let's recap. Boiling takes place throughout the liquid. Evaporation takes place on the surface of the liquid. Temperature is constant during boiling, and boiling happens at a unique temperature for every liquid. During evaporation, temperature can change until the boiling point of the liquid is reached. Change in altitude will affect both boiling and evaporation. For boiling, higher altitudes will lead to lower boiling points, so your liquid will boil faster. And for evaporation, the overall change in magnitude of temperature and pressure would determine how altitude would affect the rate of evaporation. See you in our next lesson.